Hi friends, here we are on chapter 1.7, Operations with Fractions and Mixed Numbers, from Math in Focus Singapore Math Student Edition, Course 2A. As you can see, you have addition, subtraction for the rational numbers, and you have division, multiplication for the rational numbers, and real world situation, which is only for our independent practice. If you look in your chapter, in your book, you will see that these two things are given separately, like there is a section on addition and there's a section on subtraction. Similarly, you have a section on division and a section on multiplication. But I've combined them here because of these reasons, to make our life easy, of course. Addition and subtraction, they have the same method. Okay, they have the same two further sections, like same denominator and different denominator. So it's just the sign that changes in the problem, otherwise the process is the same. So I combined it so that you feel that it's not too much. If you understand one, you can do the other one. It's that simple. Okay, and division and multiplication, basically division involves multiplication. Okay, so when you learn division, you will learn multiplication as well, and that's why I've combined them. Here we're talking about fractions, and you know fractions are in the form of numerator upon denominator, right? So that's what we are going to do in this chapter, and it says mixed numbers. Now I'm not using mixed numbers while I'm solving this, because you know how to convert mixed numbers into fractions. Do you remember? Do you remember? Do you remember that formula? It's AC plus B over C, right? I'm sure this clicks, right? So this formula, you use this formula, convert mixed fractions into normal fractions, and you are sorted over there, and then you have to follow the same process. So I'm not going to take example of any mixed numbers here. Okay, so let's get started. Let's see the addition and subtraction with the same denominator. How do we solve this kind of sums? For instance, you have 1 over 2 plus 3 over 2. Okay, so you see the denominators are same. Okay, same denominator. So in this case, whatever is asked, you do it only in the numerator. Denominator is just same. It does nothing happens to it. Okay, so it's like 1 plus 3 over 2. Denominator remains as it is. You were asked to add 1 and 3, so you did that. So this is 4 over 2, which is actually, this is 2 times 1 and this is 2 times 2, right? So this is equal to 2. Okay, so if you were asked, like for example, 1 by 2 plus 3 by 2 plus 5 by 2 plus, and so on and so forth. So simply put your denominator as it is. Don't do anything with your denominator. Keep doing things here, okay, in the numerator, and likewise. In the same way, if it was minus, okay, so 1 by 2 minus 3 by 2, right? So same, you don't touch your denominator. Whatever you have to do in numerator. So this is 1 minus 3, which is minus 2, larger minus smaller, and the sign of the larger, over 2, which is equal to minus 1. Okay, so the same denominator works like this. You don't touch the denominator. It's the same, so leave it as it is. Whatever you have to do, you do it in your numerator. Okay, now let's go to the fractions with different denominators. So for example, 1 by 2 plus 1 by 3. Okay, now do you see your denominators are not same? They are different. Okay, in order to do what you did here, the first step here is you need to get the same denominators. Okay, and how do you get that? Now we have two fractions, right? So you cross multiply, and the numerators and denominators are multiplied. Okay, so numerator has cross multiplication, right? And denominators are multiplied 2. Okay, so this is 1 times 3 cross multiplication. Okay, sorry, 1 times 3 plus 1 times 2 over denominator to be multiplied 2 times 3. Okay, so this is 1 times 3 is 3, 1 times 2 is 2, and 3 times 2 is 6. So do you see the denominator has changed? It doesn't stay either of this. Okay, this is what your denominator is now. So this is 5 over 6. Okay, so this is how you do when you have different denominators. Now here we simply cross multiplied because if you see 2 and 3, they had nothing in common. Okay, if you had fractions where denominators have something in common, then you can still do this way. Okay, let's understand this with an example. Say for example, 1 over 10 plus 1 over 15. Okay, so here you can still do as you did here, like cross multiplication, 1 times 15 plus 1 times 10, right? Cross multiplication, and then the denominators are multiplied. 10 times 15, you can do it. There's nothing wrong in it. Okay, it is just that our calculations become too big. Okay, you get big numbers. Okay, so not to get scared with big numbers, we make it a little simpler. So how do we do that? So here, if you look, 10 is what? 5 times 2, right? And 15 is what? 5 times 3. They have a common factor 5. Okay, so what I'll do is I'll do cross multiplication, but with the uncommon factors. Okay, so here 1, what is uncommon is 3, right? So 1 times 3 plus 1 times 2. Right, 5 is common, so I didn't do anything to that. Okay, and here we write 5 times 2, the fraction here, I take the first number, what is missing. From here, 5 is already covered, right? So only 3 is missing. So this is what I do. Okay, and this is basically 3 plus 2 plus, over 5 times 2 is 10, 10 times 3 is 30. So this is 5 over 30. And this is basically 1 over 6, right? 5 times 1 and 5 times 6. Okay, if you go this route also, let's just do it and see, you will still reach here. Okay, so 1 times 15 is 15 plus 1 times 10 is 10. 10 times 15 is 150, right? So this is 15 plus 10 is 25 over 150. And you know 25 times 1 is 25, 25 times 6 is 150, so this is the same. You get the same answer still. Okay, 1 by 6, 1 by 6. Here it was 10, so the calculations were pretty simple, but if you have some other numbers, the calculations can get a bit tricky. Okay, so for that sake, be careful, try the simple method, and let's take one more example further. And this time I'm going to mix addition and subtraction together and go with bigger number. So for example, 1 by 10 plus 1 by 15 minus 1 by 20. Okay, this is the equation. So here we can go this route, we can go this route as well. Okay, but now I'm going to show you another method which is simpler. Okay, if I go this route also, I can do it. It's the same method actually, but done in a different way, in the sense that we factorize and go with the process. So what are our denominators? We have 10, we have 15, and we have 20. Okay, so I put my denominators here and I start factorizing it, right? So now you have 10, so you know 2, it's divisible by 2, right? So 2 times 5 gives me 10. 2 does not have, in its table does not have 15, so we put 15 as it is. Okay, 2 times 10 gives me 20. I further factorize 10, so I know it's still possible with 2. I leave it as it is because 2's table does not have 5 and 15. Now 2 times 5 gives me 10. Now, 15, right? So which is 3, the next prime numbers. After 2, the next prime number is 3. And this is 15. 15 is 1 and 5, right? So 1 plus 5 is 6. And in 3's table, you have 6, right? So the divisibility test for 3 is this. You add all the digits and come to a final answer. And if that answer is there in the table, 3's table, that number is divisible by 3. Okay? So I do it 3, 5 stays as it is. Then you get 5 here. 5 times 3 gives me 15, and this 5 stays as it is. Right? And then I go further here. I put 5 here now. 1, 1, 1. I've reached here, right? So this is my LCM. Do you know this LCM? Least common multiplier, okay? So this becomes my denominator now. So what I'll put it here. 2 times 2 times 3 times 5, right? Which is actually equal to 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is 60. Okay, so what will I do now? My question is this, right? So the LCM, the denominator is 60. What is my denominator here? It's 10. So 10 times what will give me 60? So I'll put 1 from the numerator, and 10 times 6 gives me 60, right? So I times it by 6. Then this 1 here times. Now the denominator is 15. 15 times 4 gives me 60, right? So I'll time it with 4. Minus 1, right? This is minus. Now the denominator is 20. And this is 60. I need 60. So 20 times 3 gives me 60. Okay? So this is equal to 1 times 6 is 6, plus 1 times 4 is 4, 1 minus 1 times 3 is minus 3 over 60. 10, 6 plus 4 is 10, 10 minus 3 is 7, 7 over 60. Okay, so this is how you solve doing the prime factors over here, get the LCM. Okay, so whatever works for you the best. Try all the methods, practice all the methods, and you should be comfortable with all the methods in my opinion. Okay, so this is addition and subtraction. Now let's go to division and multiplication. In division and multiplication, let's take an example of division. So because multiplication gets covered over there, right? So for example, 1 by 2 divided by 3 by 2. How do you solve this? What do? You write 1 over 2, the first fraction as it is, no changes. This division will become multiplication, and this ratio will reverse. Okay, so it becomes 2 over 3. I repeat, the division becomes multiplication and the second ratio reverses. And then you start cancelling the common terms, right? So 2 and 2 gets cancelled. So this is 1 over 3. Okay, I hope this is clear, simple, easy to understand. Now let's understand something here. For example, so this is basically your multiplication part, right? So you don't need to do it separately, it gets covered here, and that's why I've combined them. Let's understand some basic important things here which sometimes we miss out and we make mistakes. Okay, for example, if you had number like 1 over 2 times 2 over 3 times 2 over 5, okay, how are you going to cancel them? Remember, each time you cancel something in numerator, you cancel it in denominator. It has to be this way. You cannot do, okay, let's do 2, 2, 2. This is wrong. Okay, once in numerator, once in denominator. It cannot be like this. Okay, or for example, if it was 1 over 2 times 3 over 5 times 3 over 7. Okay, so now you see there's nothing common here, right? So you don't start doing this. This is absolutely wrong. Okay? You cancel ones in numerator, you have to cancel ones in denominator. That's how it works. Not both numerators, not both denominators. Also, one numerator, one denominator and two numerators, or one denominator and many numerators, or one numerator and multiple denominators. No, it doesn't work that way. So be careful with that. Okay, let's take one more example with minus sign. 1 by 2 divided by minus 3 by 2. Now tell me, how will we solve this? Yes, right? So first fraction we write as it is. What happens to this division? It becomes multiplication. And what happens to this ratio? It is 2 over 3. It reverses, right? Remember, the sign does not get off. It stays there, okay? So this gets cancelled, equals to, this is what is left here, 1. And what is left here, 3. But this minus sign is there too. Okay, so if you had an example, like say for example 1 over 2 times 3 over 2 times 2 over 5 times 3 over 7, for example. Okay, so we are cancelling this 2 and 2. That's it. This 3 will not be cancelled. Okay, be careful with that. So this will be, you'll multiply all the terms here. So this 1 times 3 times 3, and same thing, 2 times 5 times 7. Okay, so all the denominator, all the terms in the numerator gets multiplied and become one number. Similarly, all the terminologies, all the numbers in the denominator are also multiplied. Okay, so this is how this chapter is done. Basically, you just need to understand this process of when it's same denominator, you are sorted. You simply do what you have to do in the numerator, leave the denominator at peace as it is, keep it. Okay, when you have different denominators, you have this cross multiplication is simple, straightforward. When it's, you don't have common factors. Okay, when you have common factors, you still do cross multiplication, but with uncommon factors. Okay, so here we didn't do 1 times 15. Okay, we did 1 times 3 because 5 is already covered here. So we do with uncommon factors. And here we can do this process and get the denominator, or you take the factors of first and start multiplying the factors of the remaining. Okay, so like in the first you took 5 times 2. From here 5 is covered, so you took only 3, and you can go on likewise. Okay, whether you have both the signs like addition and subtraction, you can still do that. As no matter how many fractions you have, if you have many fractions, I would suggest you go this route. It's easier, right? So even if you had another factor here, like say for example 40, you could have still learned this process. Okay, so it's better to use this route when you have many fractions to solve. So this is addition and subtraction, and then division and multiplication. So basically division becomes multiplication, and the next fraction is inversed. It's reversed, right? So numerator becomes denominator, and denominator becomes numerator basically, and multiplication is done, right? So you cancel the terms numerator and denominator. Remember this, okay? All these things, be careful. That's it in this chapter, and you're done with it. I'm sure this is simple. You need some practice, I know. So practice as much as you can. Try to understand things better. The more you practice, the better you get at it. Okay, so practice more and more and more. You watch this video, do some sums by yourselves. If you have doubts, come back to the video or pause the video, re-watch it. Make sure you get it. Make these concepts clear. Doing independent practice is much simpler. Not just that, you can solve any damn sum in the world based on this. Okay, so get the concepts clear, and math becomes much easier. So this is it. Look out for the other videos that helps you understand the other concepts and also the independent practice. Thank you very much. Math is fun. Enjoy. See you. Bye-bye.